So is it clear guys, types of errors? Yes. Now let's move on to the next topic, that is absolute error, relative error and percentage error. Yes. Let's start with absolute error. Yes. Suppose we are measuring a physical quantity n times. Yes. Since we are measuring the physical quantity for n times, yes, obviously we will get n values. Sometimes some of the values might be same, but still we get n values, isn't it? Yes. So let those values be a1, a2, a3, a4, etc. up to an. Yes. In real time situations, actually we don't know the actual value of the physical quantity, isn't it? If we know the actual value of those physical quantities, then what is the need of measuring those values, or what is the need of measuring those physical quantities, isn't it? We don't know the actual value of a physical quantity. Without knowing the actual value of the physical quantity, how do we find error and all? Yes. So actually we need to know the actual value of the physical quantity. Yes. So how do we find the actual value of a physical quantity in real time situations? In real time situations, actually we find the average of all the measured values, and this average of all the measured values is considered as the actual value of a physical quantity. So how do we find average of different values? Simple math. Suppose, say for example, there are 5 students in a class, and for physics they got marks as 92, 85, 86, 97, 75. Yes, and you are asked to find the average marks of the students in physics. So how do you find the average mark? Yes, first you will sum up all these values. First you sum up all these marks, isn't it? 92 plus 85 plus 86 plus 97 plus 75. Then you divide the total by the number of students. Here in this case it is 5. So total divided by number of students 5. Is it clear? Yes. Similarly, for finding the average, for finding the average of all those measured values, yes, we find the sum of all these measured value and divide it by the total number of measurements. Yes. We know average is otherwise known as mean, isn't it? Average and mean are one and the same. We can use either average or we can use mean. Here I am using mean for convenience. Yes. A mean means the average of all those measured values. How do we find the average of the measured value? Yes, A1 plus A2. We have to sum up all these values, isn't it? Up to An divided by n. Yes. And what is A mean? A mean is nothing but A mean is considered as the actual value of the physical quantity. Is it clear guys? Yes. So in real time situations, we generally find or calculate the actual value by this means. Is it clear? Yes. So instead of writing the whole term A1 plus A2 plus A3 up to n, we can write it in yet a simpler way. Yes. In maths we have a symbol called sigma. Yes, and this sigma denotes summation. That is, suppose it is given sigma 1, 2, 3, 4. What does it mean? It means you have to add up or sum up all the values given in the brackets. Is it clear? Yes. So here, instead of writing A1 plus A2 plus A3 up to n, we can write sigma A1, A2, A3 up to n divided by total number of measurements, that is n. Is it clear? Again, instead of writing like this, yes, we can write again. We can write it in a simpler way. How do we write? Yes. So I'm going to generalize all these measurements. using a single variable, that is I. AI. I'm going to here simply I generalized all the measured values. Simply I generalized all the measured values, replacing 1, 2, 3, 4, etc. and using a single variable I, sigma AI, where I is equal to 1, 2, 3 up to n. Is it clear? Again, instead of writing like this, we can follow another method. Instead of writing like this, we can follow another method while using sigma notation. Yes, we generally write the lower limit. While using sigma notation, we generally write the lower limit of the particular variable. We generally write the lower limit of the particular variable at the bottom, and we write the upper limit. As at the top. Is it clear? So here we can say I is equal to 1 to n. What does it mean, lower limit and upper limit? Lower limit is the minimum value, or it is the starting value that you have to substitute. Lower limit is the starting value that you have to substitute for the particular variable. And what is upper limit? Upper limit is the value, maximum value up to which you have to substitute values for the variable. That is, if it is given the lower limit is 0 and the upper limit is 9 and it is given as AI, not 9, let it be 5. The lower limit of I is 0 and the upper limit is given as 5, and you have to find summation AI. What does it mean? It means A1 plus, not A1, A0 plus. Here the lower limit is 0. So starting from 0, A0 plus A1 plus A2, it extends up to A5. Is it clear? Extends up to A5. Is it clear, guys? Yes. So here in this case, while summing up all the measured values, we have lower limit as 1 because our terms start from 1, isn't it? Yes. And it extends up to n. So our upper limit is n. So here I have written as sigma or summation I is equal to 1 to n AI. I is equal to 1 to n AI divided by n. And this AI represents each term. If suppose your terms are like, your terms in summation is like A1 into A2, not A2, let it be A1 into B1 plus A2 into B2. It is given as A2 into B2 and it extends up to AN into BN. Yes. So how do we write? How do we write this whole term using this sigma or using this summation symbol? You can write sigma AI BI, isn't it? Because here you have two terms. Each term of this whole summation consists of two terms A1 and B1, isn't it? So here you have to write AI BI and the values of I. The starting value is 1 and it extends up to n. So this is a single term which is getting repeated, in a similar manner. A1 B1, A2 B2, AN BN. Is it clear, guys? Yes. If suppose it is given A1 into A2 plus A2 into A3 plus etc. It goes on like this up to AN into AN plus 1. If it is given like this, yes, how do you write using sigma? Sigma, lower limit of I is 1, upper limit is n, AI plus 1. AI into AI plus 1. Here I have A1 into A2. What is A2? What is A2 is equal to? 2 is equal to 1 plus 1. What is 3 is equal to? 3 is equal to 2 plus 1. What is n? Is n plus 1 is equal to? N plus 1 is equal to n plus 1. So here the value of I is 1 and the value of the next value is I plus 1, isn't it? The value of I is equal to 1. The next value 2 is actually I plus 1, that is equal to 1 plus 1. 2. Again, here the value of I is 2, and the next value, the value of 3 is equal to 2 plus 1, that is I plus 1. Similarly, the same pattern is followed in all the other terms. So here I used the generalized form AI into AI plus 1. Is it clear? Yes. So this is how we write values, or this is how we write generalized terms in while using sigma. Is it clear? Yes. So this A mean is considered as the actual value of the measurement. Yes. Is it clear up to this? Yes. Now let's find the error in each measurement. The error in each measurement. Yes. How do we find the error in each measurement? For finding error in each measurement, yes, we need two parameters, that is the measured value and the actual value. Error is equal to measured value minus actual value, isn't it? Error is equal to measured value minus actual value. What is measured value is equal to, we have n different values, n different measured values. So A1, A2, A3, etc. up to An. What is the actual value? Actual value is nothing but the mean of all these measurements. The mean of all these measurements is considered as the actual value. We just discussed it, isn't it? Yes. So I am going to find the errors in individual measurements. I am going to find the errors in individual measurements. So again, we have two symbols with same name, delta. The first one is capital delta symbol, and the second one is capital delta letter, and the second one is small letter delta. And generally we use these two symbols for representing extremely smaller values. Here in this case, we know error compared to measured value and actual value, error is extremely a smaller value, isn't it? Compared to our measured values and actual values, yes, always our errors will be extremely smaller value. So for representing errors, here I am using the symbol or using the letter, capital letter del. Is it clear? Yes. So for representing the error in the first measurement A1, I am writing it as del A1. For representing the error in second measurement, I am writing it as del A2. For representing the third measurement, for representing the error in the third measurement, I am writing it as del A3, which extends up to del AN. Is it clear? Yes. So how do we find the error in A1? The error in A1 is equal to A1 minus A mean. Error in A2 is equal to A2 minus A mean. Error in A3 is equal to A3 minus A mean. Again, what is the error in AN? Error in AN is equal to AN minus A mean. Is it clear, guys? Yes. While finding simply error in each measurement, you have to note the point, simply errors in each measurement, there are three possibilities. Either you will get a positive error, value as error, or you will get a negative value as error, or you will get 0 as error. Yes. If the measured value, suppose A1, let's assume, if the measured value A1 is greater than the actual value A mean. If the measured value is greater than the actual value, you will get a positive error. Is it clear? Yes. If suppose the measured value A2, let it be A2, it is less than A mean, it is less than the actual value. If the measured value is less than the actual value, you will get a negative error. Again, if the measured value is equal to the actual value, then obviously you will get error as 0. It means no error in the measured value. Is it clear, guys? Yes. Let's discuss an example. And then let's see what is absolute error. Yes. So I measured the length of this particular room for some 7 to 8 times, and I got values as 7, 9, 6, 10, 8, 7.5, 8.5, 2, 4, 6, 7, one more value, let it be 9 again. Yes. Here we have 8 values. Yes. So I have to find simply errors in all these individual measurements. So for calculating So for calculating the error in all these individual measurements, yes, I need two parameters. One is the measured value. Here I have 8 different measured values, and also I need the actual value. Also I need the actual value of the length of the room. So actually I am not provided with any actual value. So I have to calculate the actual value. How do we find the actual value? Simply we have to find the mean or average of all these measured values, isn't it? Yes. So A mean is equal to I am simply summing up all these values. And I am going to divide it by the number of measured values, 2, 4, 6, 8. Yes. Let me do this operation in Calci, otherwise it takes so much time. Calculator. 7 plus 9 plus 6 plus 10 plus 8 plus 7.5 plus 8.5 plus 9. So we got the total as 65, and we have to divide the total 65 by 8. So I got the value as 8.125. So here in this question, what is the actual length of the room? The actual length of the room is 8.125. The actual length of the room is 8.125. So here I am writing A mean is equal to 8.125. Now let's find the individual errors, or now let's find the errors in individual measurements. Yes. So del A1 here we have 8 measurements: del A1, del A2, del A3, del A4, del A5, del A6, del A7, del A8. So what is del A and A1 is equal to, what is the error in the measurement A1? Here 7 minus 8.125. Here 7 minus 8.125. Yes. What is the error? In the individual measurement 7? It is 7 minus 8.125. That is equal to, obviously here we will get a negative error, isn't it? Why? Because the measured value 7 is less than that of the actual value 8.125. So what is the value? What is the error? Minus 1.125. Is it clear, guys? Yes. So what is the error in the next measurement? 9 minus 8.125. Here, yes, obviously we will get a positive error. Here obviously we will get a positive error because the measured value 9 is greater than that of the actual value. So here we will get 0.875. Yes. The next value is 6 minus 8.125, that is equal to 2.125. The next value is 10. So 10 minus 8.125 is equal to 1.875. Again we got the value as 8. 8 minus 8.125 is equal to minus 0.125. The next one is 7.5. 7.5 minus 8.125. Yes, 7.5 means 25. Again 11 minus 5, that is 6. Here you will get 0.625. The next one is 8.5 minus 8.125, that is equal to, again you will get 25. 0.425. Here you will get the value as 0.425, and the last value is 9 minus 8.125. Here again you will get 0.875. Yes. Is it clear? Here you will have a negative sign. Yes. Is it clear, guys? Yes. Here some of the errors are negative and some others are positive. Is it clear? There are 3 chances while finding, there are three cases while finding simply errors. Either the error values can be positive or else the other error values can be negative or it can be 0. Is it clear? When the actual value or when the measured value is exactly equal to the actual value, when the measured value is exactly equal to the actual value, yes, the error will be 0. Is it clear? Yes. How to find simply errors if you are provided with more than one measurements? Yes. Now let's see what is absolute error. What is absolute error? What is the difference between simple error and absolute error? Yes. Yes. Just now we discussed an important point, that is, while finding an error, there are three cases. The errors can be either positive or it can be negative or it can be 0. Isn't it? Yes. But while finding the absolute error, in individual measurements, there are only two cases. Either the absolute error will be positive, and if the error is 0, if the simple error is 0, then the absolute error will also be 0. So while finding absolute error, here we have only two cases. So what does it mean? It means even if the error is negative, or the error is positive, even if the simple error is negative or the simple error is positive, while we are finding the absolute value of those errors, yes, the absolute error value will always be in positive. Yes. So what does it mean? Let's try to understand it. Yes. So first let's see what is absolute error. Yes. So absolute error is the magnitude of the error value. It is the magnitude of the error value. So what does it mean, magnitude of the error value? We generally represent magnitude using this symbol, two lines. And we usually write the value whose magnitude is to be calculated in between these two lines. Say for example it is given magnitude of -2. It means you have to find the magnitude of the value -2. If it is given the magnitude of d, what does it mean? It means you have to find the magnitude of the value d. Is it clear, guys? Yes. Now let's see what is the magnitude of a particular value. If you are asked to find the magnitude of any value, then the magnitude of this particular value is equal to the numerical value alone. The magnitude of this particular value is equal to the numerical value alone. Is it clear? That is, here you have to eliminate the sign. Here we need not consider the sign. Whether the value given is positive, or negative, the magnitude of that particular value will always be the numerical value, or we can say the sign of the magnitude of any value will always be positive. If you are asked to find the magnitude of 10, then it is equal to +10. Again, if you are asked to find the magnitude of -10, it is also equal to +10. Is it clear? Yes. Here, while finding the magnitude of a value, we will not consider the sign of the value. Only the numerical value is needed. The numerical value is known as the magnitude of that particular value. So while finding absolute errors of individual measurements, yes, initially we will find the errors in individual measurement. Then what will do? Then for finding the absolute error, yes, we simply find the magnitude of the error values. Is it clear? Yes. So let's first write it in generalized form and then let's discuss an example for that. And let's move on to the next topic. Yes. So what is absolute error? Absolute error is the magnitude of the errors in individual measurement. Yes, we know the error value in the measurement A1 is equal to A1 minus A mean. Isn't it? The error value in the measurement A1, the error value in the measurement A1 is equal to the measured value A1 minus the actual value A mean. Is it clear up to this? Here we have to calculate the absolute error. Here we have to calculate not simply error, but here we have to calculate the absolute errors in individual measurement. For representing the absolute error, in measurement A1, yes, I am using the magnitude symbol. And I am writing the term del A1, whose magnitude is to be calculated between these two lines. Is it clear? Yes. So magnitude of the error in A1 is equal to, again, magnitude of A1 minus A mean. Even there, as I told before, here you have three cases, isn't it? There are three possibilities. When you calculate A1 minus A mean. Either the error value can be negative, or the error value can be positive, or it can be equal to 0. If in both the cases, that is, even if the error is negative and even if the error is positive, yes, you will get the magnitude value always in positive. If the error obtained is 0, then the magnitude of, or then the absolute error of that particular measurement is also equal to 0. Is it clear? So we can say absolute error of individual measurements will always be equal to, or will always be positive. Is it clear, guys? Yes. So now let's see an example. Yes, then we will discuss the next one, that is mean absolute error. Yes. Suppose I measured the length, not length, always we are using the physical quantity or measuring the physical quantity length, isn't it? So here I am measuring, I am going to measure the time. Okay. So I got as 2 hour, 3 hours, 4 hour, 4.5 hour, 3.5 hour. Okay, so here I have 5 measurements. And here I am asked to find the absolute error. Here I am asked to find not simple error but absolute error in each measurement. Yes. So how do I find? For finding absolute error also, yes, I need two terms, or I need two parameters. That is, one is the measured value. Yes, I have 5 different measured values, no problem. But I also need actual value. So here I am not provided with any actual time. So actually here I have to calculate the actual value or actual measure of the time. So how do I find? I find A mean is equal to, I am going to simply add all these terms. Not terms, all these values I am going to divide it by the number of values, that is equal to 5. Yes. So here I will get the values as 5 plus 4, 5 plus 4, 9, again 9 plus 1, 10, 10 plus 7, 17, that is 17 divided by 5. So what is 17 divided by 5? In 17 we have 3, 2, yes, 3.4, 3.4, am I right? Yes, 3.4. So the average or the A mean or the actual value of this time, of the physical quantity time, is 3.4 hours. Is it clear? This is the very first step for finding absolute error. So I got the actual value of this particular physical quantity. So it is 3.4 hour. 3.4 hour. Yes. Now I am going to find the errors in the individual measurements. So del A1, del A2, del A3, del A4, del A5. Yes. If you are asked to find simple errors. If you are in the question, if you are asked to find simple error, then this is your final step. Isn't this is your, once you find all the errors, once you find errors in all the individual measurements, yes, your answer is over. But actually here we are asked to find absolute error and not in simple error. So how do we find then? Once we find the error, then we find the magnitude values of those errors, or the magnitude of those errors. So what is del A1 is equal to? Del A1 is equal to A1 minus A mean. Here in this case A1 is 2 minus 3.4, and here it is 3 minus 3.4. Next one 4 minus 3.4. Next one 4.5 minus 3.4. Again last one is 3.5 minus 3.4. We know some of the given value, some of the measured values of the time is greater than the average value or the actual value, and some other values are less than, the actual value. Some other values are less than the actual value. So if we are finding simply error, some of the errors will have a positive sign and some other errors will have negative sign. Here instead of error we are calculating absolute error. So here all the values or all the absolute error values will be in positive, no matter the value, the measured value is greater or lesser than the actual value. So here I will get 1.4, 0.4, 0.6, 1.1, again 0.1. So the absolute error in the absolute error. So thus we have found the absolute error in individual measurements. Is it clear? Yes. First we have to find the difference between these two values. First we have to find the difference between these two values, and then we have to find the magnitude of the difference. So sometimes while finding the difference between two values we may get negative value, and some other times we may get positive value, isn't it? Yes. So but anyway here we are finding the magnitude, so our final answer, so all our final answer will be in positive. Is it clear? Yes. Now let's discuss what is mean absolute error. What is mean absolute error? Yes. So mean absolute error is nothing but it is the mean value of all the individual absolute errors. Mean absolute error is the mean value or average value of all the individual absolute error. So what is the absolute error? What is the absolute error of for the measurement A1? It is del A, magnitude of del A1. What is the absolute error of measurement A2? Absolute error in measurement A2 is magnitude of del A2. It goes on like this, and the absolute error in the measurement del AM. Absolute error in the measurement AN is del AN. Yes. How do you find mean absolute error? Del A mean. Let it be del A mean. Magnitude of del A mean. So what is mean absolute error? Mean absolute error is equal to magnitude of del A1 plus magnitude of del A2 etc. up to magnitude of del AN. Here we know we have a total number of measurements n, so divided by n. So we know instead of writing like this, we can write it in yet a simpler way, isn't it? Yes. So how do we write? We use the symbol sigma. Here instead of writing numbers I am using generalized form del A1, where I is equal to 1 to n divided by n. Is it clear? So what is mean absolute error? Mean absolute error is the average value, or it is the mean value of all the individual absolute error. Is it clear? Yes. So now let's see an example, and then let's move on to the next topic, relative error. So under the topic absolute error, we learned so many things, isn't it? Under the topic absolute error, we learned so many things. What all we learned? Yes. How do we find the actual value? How do we find the actual value if we are provided with so many measurements and we are not provided with the actual value? So how do we find the actual value? For finding the actual value, if we are provided with so many measurements or in real time situations also, we simply find the mean value of all the measured values. We simply find the mean value of all the measured values and it is considered as the actual value. How do we find simply errors in such measurements? Yes, we will find simply we calculate the difference between each measured value, and the actual value for finding errors in the individual measurement. There are three possibilities. If the measured value is greater than the actual value, we may get negative error. If the measured value is if the measured value is less than the actual value, we will get a negative error. If the measured value is greater than the actual value, then we will get a positive error. If the measured value is equal to the actual value, then definitely we will get no error, or we can say 0 as the error. If the next one is absolute error. So for find what is absolute error? Absolute error is the magnitude of the error value. Yes. So in the case of absolute error, absolute errors will always be in positive, because here we are only considering the magnitude of the error. Isn't it? Magnitude of the error, and here we are not considering the sign of the error. Is it clear? Yes. Then we discussed the mean absolute error. So what is mean absolute error? Mean absolute error is simply the average or mean values of all the individual absolute errors. Is it clear? Yes. Let's discuss a problem or example, and then let's move on to the next topic, relative error. So here I am measuring the mass of something. I am measuring the mass of something for some 5 to 6 times, and I got values as 9, 6, 10, 11, 7, 8, yes, 6 values. Okay. And I am asked to calculate mean absolute error, and simply error. Yes. Here I am asked to find three things. One is the simple error, next one is absolute error, and the third one is mean absolute error. Yes. Error in each measurement, absolute error in each measurement, and mean absolute error. So let's start. So before finding the error, actually I am not provided with the actual value. So I have to calculate the actual value. So actual value A mean is equal to 9 plus 6 plus 10 plus 11 plus 7 divided by 8 divided by 6. Okay, I will do it in Calci. 9 plus 6, 10, 9 plus 6, 15, 15 plus 10, 25. Again 25 plus 10, 35, 35 plus 1, 36, 36 plus 8, 36 plus 8, it will be 44. 44 plus 6, it will be 50, 51. 51 by 6. Am I right? Let me check. 9 plus 6 plus 10 plus 11 plus 7 plus 8. Yes, 51 divided by 6. So what is 51 divided by 6? It is 8.5. 51 divided by 6 is 8.5. So I got the actual value as 8.5. Now I am going to find the errors in individual measurements. So del A1, del A2, here I have 6 measurements, isn't it? Del A3, del A4, del A5 and del A6. Here instead of using the letter A, yes, you can use any letter. Instead of using letter A, you can use any letter. So for my convenience, only for my convenience, here I use the letter A. Yes, so del A1 is equal to, I'm going to find simply error. I'm going to find simply error and not absolute error. So here I have to consider the sign of the errors also. So first one is 9 minus 8.5. The value 9 is greater than 8.5. So I got a positive error. Again 6 minus 8.5. So 6 minus 8.5 means I'll get 2.5. Here measured value is less than 8.5. So I'll get a negative error. 10 minus 8.5, that is equal to 1.5. Since 10 is greater than 8.5, I got a positive value. 11 minus 8.5 is equal to 2.5. And 7 minus 8.5 is equal to minus 8.5. 8 minus 8.5, again a negative value, 0.5. So I found, here we found the errors in the individual measurement. Now the next question is to calculate or to find the absolute error in the individual measurement. So it will be like this, isn't it? Yes, here we have to calculate the magnitude. Here you have to calculate the magnitude. So while calculating magnitude, yes, here we have to consider only the numerical value. Here you have to consider only the numerical value and not the sign. So all the values of or all the absolute errors will always be in positive. Is it clear? Then I am asked to find mean absolute error. So how do I find mean absolute error? Mean absolute error is nothing but the mean value of all those absolute errors, isn't it? So 1.5 plus 2.5 plus 1.5 plus 2.5 plus 1.5 plus 0.5 divided by 6. 1.5 plus 1.5, 3. Again 2.5 plus 2.5, that is 5. 1.5 plus 0.5 is equal to 2. So 3 plus 5, 8 plus 2, 10. 10 divided by 6. Let me check. Am I right or not? 1.5. 2.5, again 1.5, 2.5, 1.5 plus 0.5, got the value as 10. 10 divided by 6 is equal to 1.66. So here we can round it off as 1.67. So what is the value of, what is the measure or what is the value of mean absolute error? We got the value of mean absolute error as 1.67. So this is how we calculate simple error, absolute error and mean absolute error. Is it clear? Yes. Yes. So the next error is relative error. Relative error, yes. So what is relative error? So what is relative error? First I will write the definition of relative error. It is the ratio of mean absolute error. Mean absolute error to the mean of measurements or measured values or measurements. Mean of, I'll write measured values. Mean of measured values. Or otherwise, we can say it is the ratio of error in measurement to the ratio of error in measurement, to the actual value. Absolute error in measurement to the actual value. Is it clear? Absolute error in measurement to the actual value. Yes. So, what is relative error? Actually, relative error is a ratio. It is the ratio of the mean absolute error. It is the ratio of the mean absolute error, that is del A mean. Del A mean and to the mean of the measured value, that is A mean. To the mean of the measured value, that is A mean. If you are provided, if in the question you are provided with so many measurements, if you as in the example which we discussed earlier, if you are provided with so many measurements and then you are asked to find the relative error or absolute mean absolute error, etc., then you have to follow this equation, or then you have to follow this definition, that is relative error is the ratio of mean absolute error to the actual value. Sometimes they may provide you in the questions, they may provide you with the values such as actual value and a single measurement. You will be provided with one actual value and a single measurement. If it is provided like that, then you have to find the absolute error. You have to find the absolute error and then divide it by the actual value. Is it clear? Yes. If you are provided with so many measurements and you are asked to find the relative error or something like that, so initially you have to calculate the mean absolute error and then you have to divide it by the mean value of all those measurements. Sometimes in question, instead of providing you with so many measurements and all, they will provide you with a single value, with a single measurement and the actual value. So in such cases, how do you find the relative error? So you will find the relative error using this equation, that is error in the measurement divided by actual value of the physical quantity. Is it clear, guys? Yes. So let's see an example. The first example is the actual value of the current flow. The actual value of the current flow in a circuit is 5 ampere. It is 5 ampere. When I measured the current flows in the circuit, using an ammeter, I got the value as 3 ampere. So here I am asked to find the relative error in this measurement, particular measurement. I am also asked to find the absolute error in this measurement. Yes. So how do you find the absolute error in the measurement? For finding the absolute error, yes, you need two parameters, that is individual measurement, measured value and actual value. Here you are provided with two values directly. The first one, 5 ampere, is the actual current flow in the circuit, and the value 3 ampere is the value you obtained while you measured it using an ammeter. So here how do you find the absolute error? Absolute error del A is equal to, yes, magnitude of measured value minus actual value, isn't it? Yes. Here the measured value is 3 and actual value is 5. The magnitude of, even though the error is in negative sign, simply error will be negative error, that is -2. Here we are asked to find absolute error, so it will always be in positive. So absolute error of this particular measurement is 2. Is it clear? Yes. So we got the value of absolute error as 2 ampere. Again, the next question is to calculate the relative error in this measurement. So how do we find relative error in the measurement? So I know relative error is equal to, yes, absolute error divided by actual value, isn't it? Here I am provided with a single measurement, or I am provided with all the values directly. So for finding the relative error in the measurement, yes, I have to simply divide the absolute error by actual, that is 2 ampere divided by 5 ampere. This since the units are same, they'll get cancelled. Since the units are same, they'll get cancelled. So wherever we use the term ratio, wherever we use the term ratio of similar quantity, wherever we use the term ratio for or ratio of similar quantities, yes, those values will not have a unit, or those ratio values will not have a unit. Only if the physical quantities are one and the same. Is it clear? Yes. So here both the physical quantities are one and the same, isn't it? It is current flow. So the units are same, so it got cancelled. So that is 2 by 5 is equal to 0.5. So what is relative error of this measurement? Relative error of this measurement is equal to 0.4. Is it clear? Yes. So we will see one more topic, and next we will see what is percentage error. Okay. Yes. So here same, I measured the voltage. Here instead of current flow, I am measuring voltage using a voltmeter, and here I got values as 2 volt, 3 volt, 5 volt, 4 volt and 3.5 volt. Here I have to find absolute error. And relative error. Okay, not absolute error. Here I have to find relative error. Yes, I have to find relative error. So for finding relative error, we know for finding relative error we need two values or two parameters. One is mean absolute error. And the other one is actual value, or we can say mean of measured value, isn't it? Mean of measured values. Here in this case we need actually the value of mean absolute error and the mean of measured value. Here we are not provided with these two values directly, so here we have to find. So how do we find the mean absolute error? For finding mean absolute error, initially we need, what do we need? Actually we need individual absolute errors. So here we have 5 values: del A1, del A2, del A3, del A4 and del A5, isn't it? Yes. So here magnitude of 2 minus, initially I have to find the average. Okay, A mean is equal to 2 plus 3 plus 5 plus 4 plus 3.5 divided by 5. Here while finding the average values, you have to note one point. Here you have to consider the units also. All the units should be one and the same. The units of all the values should be one and the same. Is it clear, guys? Here the units of all the values are given in volt, so there is no need of conversion of units and all. Yes, so we can directly use these values: 2 plus 3 plus 5 plus 4 plus 3.5. so 10, here we will get 10 plus 4 14, that is 17.5 divided by 5. So here I will get 3 and balance 2, isn't it? 3.5. Here the average or the actual value is 3.5. So I got it as 3.5. So 2 minus 3.5. 2 minus 3.5, that is 1.5. 3 minus 3.5, that is equal to 0.5. 5 minus 3.5, that is equal to 1.5. 4 minus 3.5, that is equal to 0.5, and 3.5 minus 3.5 is equal to 0. Here the measured value and mean value is one and the same. So in the case of the last measurement, actually the error value is 0. So the next step is to find the mean of these absolute error. So 1.5 plus 1.5 plus 0.5 plus 0.5 plus 0 divided by 5. 1.5 plus 1.5 plus 0.5 plus 0.5 plus 0 divided by 5. Yes. So we'll get 1.5 plus 1.53 plus 4. Yes. That is equal to 0.8. Here the mean absolute error value is equal to 0.8. I got the mean absolute value as 0.8 and I know the actual value or the mean of the measured value is 3.5. So what is relative error is equal to? Relative error is equal to mean absolute error divided by 3.5. Here you will have units, volt. Unit is a must. Here you have unit, the units is same. The units are same. So once if you divide these two values 0.8 and you divide 0.8 by 3.5, you will get the value of relative error. Yes. And the next one is percentage error. Percentage error. So what is percentage error? Relative error expressed in percentage is known as percentage error. Yes. How do we calculate? The percentage value of something? Yes. If the relative error is given as RE, the value of percentage error is equal to relative error into 100. Is it clear? That is, we generally use the symbol del A. We generally use the symbol del A. Here the del letter is small letter. Yes. Del A for representing percentage error. Del A is equal to mean absolute error. Mean absolute error divided by A mean into 100. Is it clear? What is percentage error? Relative error expressed in percentage is known as percentage error. So if you are provided with the relative error value, simply multiply it by 100. Or if you are given certain number of measurements and you are asked to find the percentage error, first you have to calculate the absolute errors in individual measurements. Then you have to find the mean absolute error. Then you have to find the relative error value. So if you are provided with so many measurements and you are asked to find the percentage value, first you have to find the mean of those measurements, isn't it? Yes, the first step is to calculate the mean of those measurements and the next step is to calculate the absolute errors in individual measurement. The third one is to calculate the mean value of those absolute error and the fourth one is to calculate the relative error and finally you will find what is relative error in percentage. What is relative error in percentage for calculating the percentage error in the measurement. Is it clear? Yes. Is it clear? Absolute error and relative error and percentage error? Yes. So now let's discuss some problems on these three topics: absolute error, relative error and percentage.